Looking good, everyone. All right, go ahead, get your answers up on the board. I do see tons of people up there now. I'm going to go ahead and send out the notes then now. So please make sure you open up your notes right there. And remember, try both links. One will work, one won't. Otherwise, you can always go to your grades tab. It's always in your grades tab. It's always, it's also in your announcements. It's in your class plan. It's also in your content tab. So lots of places to get to it. Make sure you have your notes open because part of your attendance is, did you do your notes during class? Again, you can do your notes at any time, right? So notes at any time will give you notes credit, right? But if you do notes during class, that will also give you attendance credit. All right, so remember, I don't have an attendance word or anything. I just check, did you do your notes, which we were doing during class? During class. That's all I check. All right, perfect. Calms you down. Oh my goodness. So she was 4 years old. How tall are you? Because I feel like sometimes if you start drinking caffeine that early, it can make you a little bit shorter than average. All right, perfect. Let's go ahead and start going over these answers. What type of matter is a chocolate chip cookie? Taking a look here, we obviously did not have a chemical formula, so it's not something that is like made up of just one type of atoms. So instead, this is actually a physical mixture. Perfect. And taking a look at here at the two different types of physical mixtures, is it uniform, the same, that would make it homogeneous, or not, that would make it heterogeneous. So taking a look here at the bottom of a chocolate chip cookie, think about how that's often kind of burned, how you can actually pick out the different chocolate chips, how the sides of a chocolate chip cookie are different than the center of a chocolate chip cookie. All of those samples are different, and so no, it does not look the same, and therefore would be a heterogeneous mixture. Remember that prefix hetero meaning different. Right, so each sample of the cookie will look a little bit different, have a different number of chocolate chips, etc., etc. Oh my goodness. Yeah, I'm only 5'2". I did not start drinking coffee till I was in college, but yeah, I'm only 5'2". So my daughter is going to be a lot taller than me because her father is like 6'2". So all right, awesome. Let's go ahead and take a look here at then at talking about theobromine. Theobromine, we do have a chemical formula for C7H8N4O2. So this is clearly something that's made up of a specific type of atoms. That makes it a pure substance. And so figuring out which type of pure substance, a compound or a element, depends on if it's made up of different types of atoms or one type of atom. So the question here is, can the pure substance be separated chemically into different atoms? The answer here should be yes, it definitely can. It is a compound because it's made up of carbon, hydrogen, nitrogen, and oxygen. It's not just a single type of atom. It's many types of atoms. Therefore, yes, it is a pure compound. Excellent job on this, everybody. Again, please make sure if you don't already have your notes open that you get them open, because if you do them during class, that is how you get your attendance. You can't just log in for attendance. You do actually need to do your notes and pass them during class time. Okay, yeah, if you're having trouble with your stuff, let me know. I don't know why New Row is glitching out right now. All right, let's go ahead and take a look here. This is a reminder, please do not share contact info. Please make sure you are participating often and well and behaving appropriately. And don't forget that these sessions are being recorded. We are on day 6 out of 60, 10% of the way through our trimester. We're going to be talking about phase changes today. This is a reminder that if you are in the yellow box right here, you are a new student for trimester 3. And as a new student, you are required to take STAR 360 at both the start and end of the trimester. So remember, you should have done reading yesterday at 1 p.m. and you should do math today at 1 p.m. Find those sessions on your live session schedule. Please make sure you don't skip those, because otherwise this STAR 360 team is going to come and hunt you down, and that's way less fun than just doing it right away. Okay, still not working. Okay, perfect. All right, so that means that everybody else, though, all old students and new students, you will then be required to take it at the end of the trimester. So again, new students start and end of Tri 3, old students only the end of Tri 3. Those will be proctored during normal classes in about 2 months. Please do not take them before we actually proctor them. Otherwise, it will not count towards your STAR 360 credit that you get in all of your classes, and it also won't be helpful for us to know your actual data of whether or not you are improving at your reading and your math. Okay, Yeah, no worries. Yeah, try a browser or a different tablet. Yeah, there's a couple things, but otherwise, well, I guess you can't hear me. All right, but good advice in the chat box. Yes, please keep helping your peer out. Keep helping your classmate out. All right, so today we're going to take a look at phase changes and identify the different types of phase changes and talk about endothermic versus exothermic processes. We're going to be working on the 1E notes. I'll send those links in the chat box again. I do have about 5 of you with your hands raised already. All right, go ahead and raise your hands and let me know that you are good on opening up your notes. Oh yes, I do have the YouTube one recording right now, but you are right. I should also record through New Row. I will do that as well. Thanks for reminding me. All right, perfect. Go ahead and raise your hands. I will give you 20 more seconds, everyone. Let me know if you're having any issues. Otherwise, raise your hands and let me know that you are working on your notes. Again, you have to pass your notes during class if you want attendance. There's no other way to get attendance. You can't just log in and get attendance. You have to do your notes during class. 5 seconds remaining. Let's take a look at this picture on the left. Is heat being added to or removed from water when it is boiled into steam? Tell me in the main chat here. If I put this water onto the stove, what am I trying to do? Am I trying to add heat to the water or am I trying to remove heat from the water? Go ahead and tell me in the chat. Thank you. Yes, absolutely. We are trying to add heat to this. All right. And if we're adding heat to it, what do you think is going to happen to the temperature of the water? Is it going to increase or decrease? Will it get hotter or colder? Tell me in the chat box, is it going to get hotter or colder? Temperature increases, decreases. Yeah, it's going to rise, it's going to increase, it's going to get hotter, absolutely. And as it turns into steam here, all right, those steam particles are chaotic, so do they have more motion or less motion than the liquid that they started as? Again, chemically they're not changing, but their motion is changing. So what's happening to the motion of these steam particles? Are they faster, slower, or slower? More motion, less motion? No worries, Genesis. Thanks for letting me know. You are all good. Yeah, so absolutely, these are going to be faster, right? So they're faster. The particles are more chaotic. Absolutely. So as we add heat, which is thermal energy, we are getting hotter. We are getting faster. Excellent. Now let's think about the reverse. All right. Let's say that we put our water into a freezer. What is the freezer trying to do? Is it trying to add heat or remove heat from the water? All right. So here's my freezer. Here's my cup of water. What is going on here? What is the freezer doing? Yeah, it's trying to take away heat or remove that heat, absolutely. So it's actually stealing that heat away. And as it steals that heat away, what happens to the temperature of that water? Does it get hotter or colder? Think about yourself. If you're losing heat, are you going to get hotter or colder? Absolutely, yeah. If it's freezing into ice, it's definitely getting colder. And we can see here that as it freezes into ice, it gets more rigid and unchanging in terms of shape and volume. And so if it's not changing shape, not changing volume, getting more rigid, in this case, do those particles have more or less motion? More or less motion, you can also think about it, are the particles moving faster or slower? More or less motion, faster, slower? Tell me in the chat. Yeah, they definitely have less motion, right? They're still kind of vibrating in place, but they definitely have less motion. They're moving much slower, so colder and slower. So as we add heat, you get hotter and faster. As we take away heat, you get colder and slower. And this can cause you to actually change from one phase to another. And that's what we are taking a look at today. We are looking at phase changes. So here we go. When matter changes from one state, a solid, liquid, or a gas, to a different state, solid, liquid, or gas, this is called a phase change, and this happens due to heat energy or thermal energy, either being absorbed, being added to it to make it hotter and more chaotic, or thermal energy being lost and released by the substance, removed from the substance, making it slower and colder. Now remember again that these processes are only physical changes. They are not chemical changes because chemically the substance is still chemically the same. For example, tell me again in the chat box, solid, liquid, and gaseous water are all still what? Chemically, what is their formula? What is the chemical formula for water, whether it's a solid, liquid, or a gas? Thank you, Luca. Thank you, Evangelina. Yes, they are all H2O. That is not changing. The only thing that changes is their motion. Remember, gases are the most chaotic and hottest. Liquids are a little bit less chaotic, but they can still move and flow. And solids are the least chaotic. Their particles are kind of vibrating and stuck in place, and they maintain their shape and volume. Okay, this is going to be number 2, which I see many of you already figured out. Go ahead and fill in the blank with the word physical, only the word physical. Make sure you spell it correctly. Capitalization does not matter, but spelling does. You have 20 seconds to raise your hands. These phases, I'm betting you're actually pretty familiar with a lot of them, with a lot of these different phase changes. For example, let's think about melting. If we have some ice cream that starts out as a solid, we take it out into the hot sun, it begins to melt. It's turning into what state? Tell me in the chat box. Tara already knew what I was going to ask. What is it turning into? It's going from a solid to a what? As your ice cream melts, it's turning into a sad liquid. Yes, a sad, sad liquid. Now, the reverse then would be freezing. Freezing is when you go from a liquid to a solid. So let's say we take that ice cream, we get it into a freezer nice and quickly, it'll turn back into a solid. So these two things are opposite processes. They're opposite. Solid to liquid is melting, but the reverse, liquid to solid, would be freezing. Definitely a nightmare. I agree, Alexis. Now, let's go ahead and talk a little bit about vaporization. You can actually see the word vapor in here. So what do you think this one is doing? It's turning from a liquid into a what? There are 2 types of vaporization, if this helps. There's evaporation, and there's also boiling. All right, so if that helps you think about what it's turning into, go ahead and tell me in the chat. Yeah, water vapor is what state? Is it a solid, liquid, or gas? We often use water because water is the most familiar example, but let's talk about the actual state. Yeah, it's going to turn into a gas, right? So a liquid to a gas, evaporation, boiling, we get that steam, for example, or that water vapor, and absolutely that is the gaseous form of water. Now, condensation might be a little bit less familiar to you, but how many of you have ever had a cold drink, taken it outside on a hot day, and then suddenly your drink starts to sweat? Yes or no? Tell me in the chat box if you've ever experienced that. Sweaty drinks. Sounds disgusting. All the time, right? Especially in California where it gets a lot warmer than it might in other places. Yeah, especially with soda cans. Yes. All right. This is not actually sweating because that's disgusting. Yeah, sweaty drinks. Don't quote me on that. This is actually condensation. Yeah. Oh, it's true. They do get very slippery. So what's happening here is we have gaseous water in the atmosphere that just exists naturally around us. It's called humidity, right? If there was no gaseous water in our atmosphere, our skin would dry out and we would crumble into dust. All right, so we need some water in our atmosphere, otherwise it gets too dry. Okay, so what happens here is we have water in our atmosphere, and as it's on a hot day, as it hits a cold drink, that cold drink cools down that gas. And as it cools down that gas, that gas is going to condense. It's going to come back together. It's going to become less chaotic. It's going to become cooler, meaning it's going to turn back into a liquid. So a gas into a liquid. Smiley faces or emojis in the chat box if that makes sense. Smiley faces or emojis in the chat if that makes sense. Yeah, especially, yeah, so windows will get condensation. My glasses get condensation when I'm wearing a mask on cold nights. I don't know why it's blurry. It might be just because you're on your phone and I'm typing with the pen. Just do your best. Do your best. All right, now these new ones at the bottom, sublimation and deposition, might be a little bit newer to some of you. So sublimation and deposition are both different processes where they actually completely skip the liquid phase. Okay, so for example, you can see here that this solid dry ice is also known as solid CO2, carbon dioxide. It's not water, even though it has the word ice. It's not H2O, it's CO2. This solid ice right here is turning directly into what? Take a look here. What do you notice is coming off of this solid ice? Yeah, don't eat the solid dry ice. It will burn your tongue. You have to handle it very carefully because otherwise it can burn your hands and burn your tongue. Yeah, yeah, it turns into a gas, directly into a gas. Yes, dry ice is a lot of fun to play with. You might get it in like packages if people ever send you like food. My parents like to send me Chicago deep dish pizzas during the holidays. You all right there, Kaylee? And so we always get dry ice. So we play around with the dry ice around the holidays because it's a lot of fun to play with. But please be careful with it. Make sure you wear gloves and don't touch it very, very long because you can get dry ice burns, cold burns from it being so cold against your skin. All good, Kaylee. Yeah, it's a lot of fun. Yeah, so if you put it in liquid, it turns into that gas. You can kind of make it look like your glass is like smoking. It's really cool. Really cool. Oh, that is a big cat. That is a big cat. All right, deposition then is obviously going to be the opposite because the other side has always been the opposite so far. So this is when we go from a gas to a liquid completely, again, skipping the liquid phase. All right, now, this is important to understand. Just because something ends as a gas does not necessarily mean vaporization. All right, vaporization, it has to start as a liquid, whereas sublimation, it has to start as a solid. Same thing over here with deposition. Just because it ends as a solid does not mean it's freezing. If it starts as a gas and goes straight to a solid, that is actually deposition, not freezing. Okay? So taking a look here, focus everyone, focus. All right, again, we have gas in our atmosphere, gaseous water in our atmosphere, and on really, really, really cold nights, right before winter starts, you get what's called frost. And what's happening here is that this time the surface is much colder than your cold glass of water from condensation. So this time it's much colder, and because it's so cold, it actually just skips that liquid phase, goes straight to a solid, and crystallizes on your plants and on your grass, creating frost. So that is deposition. All right, perfect. Go ahead and give me a green check, orange X if these are beginning to make sense. Make sure you start committing that vocab to memory, especially sublimation, deposition, because we will have a check for understanding on it in just a few slides. Perfect. All right, let's go ahead and start off with those basic ones, though, the ones that we should be most familiar with: melting, freezing, vaporization, and condensation. Go ahead and match those up for me up on the board. Go, go, go. Match those up for me up on the board. Oh, excellent, Alexis. Your cat's name is Cholo. I love that. That's great. 20-pound cat named Cholo. Excellent. Excellent. Seeing lots of great answers up on the board. Keep on working up there. Make sure you're participating. Even if you see other people with the answers, you should always participate because it helps to reinforce your own learning. Doesn't help you to watch other people learning. It only helps if you're also practicing it yourself. Perfect. Let me go ahead and pause these tools. Yes, melting is where we go from a solid to a liquid, like our sad ice cream. Freezing is how we fix our ice cream by sticking it into the freezer, turning it back into a solid from the liquid phase. Vaporization, again, is evaporation or boiling. Both of those will go from a liquid to a gas. I did have a couple mistakes there, so make sure you double check in your own brain. Make sure you correct that in your own brain if you haven't already. Vaporization, again, is this idea of turning into a gas from a liquid, vapor. And finally, taking a look here, condensation. Condensation is where we are going from a gas to a liquid, right? So it condenses on the outside of a cold can, for example. I know. Don't worry. I have a cleaned up version just for you, Meza. This is going to be number 3. Please raise your hands for number 3. You have 30 seconds to match these up. Go, go, go. Raise your hands once you're ready. If you need help, I'm in the chat. Go, go, go. All right, everyone, let's go ahead and work on this question up here. So water forms on the outside of a cold can of soda. What is that an example of? Freezing, condensation, or deposition? Get your answers up on the board. The sun dries the sidewalk after a rainstorm. We've got some liquid water on the ground, and then it begins to evaporate. Is that melting, vaporization, or sublimation? These ones on the right are a little bit trickier. Let's think back to that new vocab that we learned. Again, dry ice, which is solid CO2, turns directly into a gas when heated. So is that melting, vaporization, or sublimation? Again, it's skipping the liquid phase. Skipping the liquid phase. Skipping liquid. And same thing down here. This one is actually also skipping the liquid phase, but in reverse, right? So frost forming on a leaf goes from a solid to a gas. Again, we're skipping the liquid phase. So there's some new vocab that we need to remember for that last one. Perfect. Getting lots of good answers. I do see people fixing their answers down there. That's awesome. It's okay to make mistakes as we're learning new things. So just make sure you're fixing them as you realize you make a mistake. Yeah, almost lunchtime, Shane. Don't worry. Looking good. All right, let me go ahead and pause these tools. Looks like most of these we were pretty unanimous on. Yes, this is condensation. Remember, going from the gas in the atmosphere to the liquid on the can. The sun drying the sidewalk, that's liquid water turning into a gas, right? It's not actually disappearing, it's just turning into a gas going back into our atmosphere. That is vaporization. Dry ice turning immediately into a gas, that is sublimation. Again, solid to gas, skipping the liquid phase, that is our new vocab word, sublimation. And frost forming on a leaf, we talked about this one, also skips the liquid phase but in reverse. So this one should actually be deposition. It is not freezing. Freezing would be going from a liquid to a solid. Here though, we're actually going from the gas in the atmosphere straight to a solid. Go ahead and give me a smiley face or a emoji or a yes in the chat if that makes sense. The correction down here for this one. If we skip the liquid phase, it's not freezing, it's actually deposition. Beautiful. All right, everyone. Let's go ahead and work on 4, 5, and 6 together. These ones are all complete on your own, so please do not put answers in the chat, but I will be in the Q&A chat to help. So let's start off with number 4 together. In cold weather, water that drips from roofs becomes icicles. What is the starting state? Do not put answers in the main chat. All right, but let's go ahead and take a look here. Starting state is that water drips. So you want to be thinking about water dripping. That means water is flowing. So you should think, if it's flowing, I should know what state that is, a solid, liquid, or gas. Please work on number 4. You have 20 seconds to answer that one. If you need help, I'm in the Q&A chat. Go, go, go. What is the ending state then, right? So ending state is number 5 here. So it becomes icicles. So for this one, we want to think about how icicles are rigid and they have unchanging shape. So you should be able to think, is that going to be a solid, liquid, or a gas? Go ahead and answer number 5 and raise your hands. Oh, sorry, let me lower the old hands. 20 seconds to raise your hands for number 5. Again, only if you need to, please check number 5. Otherwise, I'm having a hard time keeping up with everyone. So then for number 6, what type of phase change would that actually be? Think about what it starts as, think about what it ends as. You should be able to figure out, is that condensation, deposition, freezing, melting, sublimation, or vaporization? If you need to check your answer, I'm in the Q&A area. I'll go ahead and give you 20 seconds to work on that one. Go, go, go. I know most of you already have it done, but let's give some time to the remaining people. Go, go, go. Number 6, raise your hands. Next thing we're going to learn about is endothermic versus exothermic processes, which we actually already discussed at the start of our class. Now we're just going to go ahead and add some vocabulary to it. So the word endothermic, if you think about the prefix endo, you should think of the word enters. So endo means enters, and so endothermic means that heat is entering the substance. So if a process is endothermic, that means that heat is being added to it. So as thermal heat as thermal energy or heat is absorbed into the substance, added to the substance, it's going to get hotter. The particles are going to move faster because they have more kinetic energy. That thermal energy turns into our kinetic energy or our motion energy. So anything that gets hotter and more chaotic is an endothermic process. For example, melting and evaporation or vaporization, both of these make the particles move faster. Solids turn into flowing liquids. Liquids turn into chaotic gases. Particles move faster and faster and faster. And they're also getting hotter and hotter and hotter, right? Ice is the coldest version. As it turns into liquids, they get warmer. And as they turn into gases, they get hotter. So that's melting, vaporization. This could also be sublimation. Again, if we skip that liquid phase and go straight from a solid to a gas. Please go ahead and fill in number 7. Fill in the blank with the word enters. Only the word enters. Capitalization does not matter, but spelling does. 20 seconds. Raise your hands. Yes, you do need to have that last S. Yeah, make sure you spell it exactly as you see it. I do try to go back and give points based on spelling mistakes, but once students start turning notes in late and stuff, it's not as easy for me to check for spelling mistakes based on how K-12's grading process works. Thank you, Jasmine. You're funny. Yeah, you're like, this is the hot one. I'll put some fire. All right, Brandon, Destiny, Shane, Andres. Press. Thank you, Brennan. Thank you, Press. Waiting on Dane. Thank you, Dane. John, Gino, Paul, Julia, Angelina. Why is that, Shane? Perfect. All right, let's go ahead and take a look then. If endothermic means heat enters, what do you think exothermic means? Take a look at this vocab. What do you think exothermic then means? Yeah, endo means enters, therefore exo means exit. So heat exits here. So this time we're losing heat. So thermal or heat energy is going to be lost or released from the substance. As it gets lost, it's going to decrease in temperature. Just like you, if you lose heat, heat exits your body, you are going to get colder. So you're going to decrease temperature as well as decrease your motion. The particles get less chaotic, less motion. They have less thermal energy to turn into kinetic energy, so they don't move as much. So this time, any process where you get colder and slower is going to be exothermic. For example, freezing, right, going from liquid water to solid ice, the particles get less motion. They suddenly freeze into place. They get more rigid, as well as they get a lot colder. Versus, right, going from vaporization to liquid water or gas to liquid water, condensation, that would also be an exothermic process. Yeah, perfect. This is number 8. Go ahead and raise your hands for number 8. You have 20 seconds. I see Tara, Genesis, I see Matt, Julia already. Awesome. Endothermic and exothermic processes, all of the phase changes that we learned are endothermic and exothermic processes. So for example, condensation, we get colder, the particles get slower. It must be losing or releasing heat. Tell me in the chat box, therefore, is this endothermic, heat enters, or exothermic, heat exits? If it's losing or releasing heat, getting colder and slower, tell me in the chat, is this endo or exo? Endo or exo? Thank you, Luca. Thank you, Jasmine. Thank you, Tara. Thank you, Alexis. Yeah, it's going to be exothermic. We can see heat exiting. Vaporization, on the other hand, going from a liquid to a gas, means gases are hotter. They're also more chaotic. Particles are moving faster. To get hotter and faster, you must be absorbing heat or adding heat to that substance. Therefore, is heat entering endothermic or exiting exothermic? Is this endo or exo? Tell me in the chat box. Vaporization, is that an endothermic or an exothermic process? Thank you, Tara. Thank you, Matt. Yes, Camilla. Awesome. Umeza. Rosa. Perfect. Yeah, this is going to be endothermic. Excellent. Go ahead on the whiteboard. You should be able to do the rest. All right. Think about any time you get colder and slower, you are losing heat. So what process is that for freezing and deposition? And anytime you get hotter, you are getting faster, more chaotic. You must be absorbing heat, adding heat. So is that endo or exo for melting and sublimation? All right. Anything where you get hotter and faster is the same. Anything where you get colder and slower is the same. Beautiful, beautiful. Yes, absolutely correct. Yes, so freezing and deposition are both processes where we get colder. We turn into solids like ice. They're getting slower. That's why they are solids, because they're rigid. Particles are unable to move easily. And so you must be losing heat. Losing heat means heat's exiting. That's exothermic. Melting and sublimation, you're getting hotter and faster, turning into liquids and gases, which are more chaotic. And so you must be absorbing heat. Heat is entering. That is endothermic. Excellent job on that one. Let's go ahead and work on number 9 together. All right, I'm going to help you out with most of these. There's just one part that you need to answer on your own. So a solid chocolate bar is placed outside in this hot sun. Tell me in the chat box, what phase change do you think will happen? Solid chocolate bar being placed in the hot sun, what phase change will you think will happen? Right, we have condensation, we have vaporization, melting, freezing, deposition, sublimation. Yeah, it's definitely going to melt, right? So we're going to melt, meaning that we are going from a solid to a liquid. All right, so if it's in the hot sun, what do you think is happening to temperature? Is temperature decreasing or increasing? Is temperature decreasing or increasing? Yeah, exactly. So temperature increases. Perfect. All right, so I have that one. Can you see my note up on the new row? I did say to broadcast note. I don't know if it's actually. Okay, perfect. Yeah, so temperature is going to increase. Perfect. And what about their particles? If you're turning into a liquid and the particles begin to flow, does that mean particles are moving faster or slower? Think about in a solid, they're stuck in place. In a liquid, they can flow. So are they moving faster or slower? Yeah, absolutely. So particles move faster. Excellent. And so what does that mean must be happening to energy? Is it absorbing energy or is it releasing energy? In order to get hotter and faster, should it be absorbing energy or releasing energy? Yeah, it should be absorbing energy. So thermal energy is absorbed. We have to add energy for that to happen, for it to get hotter and faster. Okay, so all you need to do then, friends, is just figure out, is it an endothermic or an exothermic process? Don't put your answers in the chat right now. If you want to check, I'm in the private Q&A chat. All right, you have 30 seconds to go ahead and finish up number 9. I gave you 3 answers in the note area, so just go ahead and answer that last one. Is it an endothermic or an exothermic process based on what's happening to our thermal energy? Think again about those prefixes, endo and exo. Go, go, go. Answer number 9, 30 seconds. Raise your hands. We talked about phase changes, the different types of phase changes, endothermic and exothermic processes. Make sure that you do that last question, just saying that you understand you need to do the projects in order to pass the class. Go ahead, submit that. Let me know if you got A's and B's. Want to shout you out in the chat box. Remember, you do need to make sure you pass the notes during this time so that you also get your attendance. All right, if you want attendance, make sure you're here. Awesome. Great job. Congratulations, everyone. Thank you so much. Have a wonderful day. I will see you tomorrow. You have 30 seconds to go ahead and log on out. If you have a question, speak now or forever hold your peace, and I will see the rest of you later. Bye, everyone.